Right, temperature monitoring using the Raspberry Pi and Falcon Player. That's a little picture of my actual controller box, which I did bring along with me. Here it is. So this is my actual controller box, which has got everything in it. So power supply, Raspberry Pi, my E682 fans, and all the temperature sensors and stuff in there. It's all controlled wirelessly, so I can just connect directly to this. All I needed outside, power plugged in, hooked up to the tree, and that's it. As you can see from the picture there, it's actually got the temperature overlaid over the top of a picture of the control box. So I've managed to actually do that all using HTML and PHP to actually do it. So we can run through how I'm actually doing it. So for basically $2 worth of parts, you can actually do this. So if you're running Raspberry Pi and the Falcon Player software, $2 worth of bits, a little bit of time, bit of effort, bit of energy, you can do that. So Falcon Player software, a DS18B20 sensor. Those are the sensors that actually have been found to work really quite well. A little controller board and your laptop, your tablet, your phone, whatever you want, right? As long as it's connected up, you can actually use that to monitor the temperature. So to actually get it all set up and running, all we need to do, we need to modify a couple of files that are there standard on the actual Falcon Player software and the Raspberry Pi. So we need to actually connect up to the Raspberry Pi. Now, the easiest way to do that is via the Falcon Player software, and we create an SSH shell session into the actual Raspberry Pi. The way that the Raspberry Pi with the Falcon Player software is set up is you don't have a GUI on there at all. You've just got command line. So you can plug your Raspberry Pi up to your HDMI monitor and have your keyboard and mouse connected, or you can do it just from your laptop and just connect up to it this way. Either way, it doesn't really matter how you do it. So you load the SSH shell screen in your browser, log in. Default setup is username of FPP, password is Falcon, and then that brings you up to your command line interface. So that command line interface, that's it. That's all you get with the Falcon Player software installed. If you were to actually install Raspbian on the Raspberry Pi, you can actually have a GUI interface, and you can use your mouse, keyboard, click around, do what you need to do. But this way, they've actually stripped that GUI out completely of it, as it's not required. Personally, I don't understand why they did that. I don't think it would really reduce that much load just to have the StartX X GUI there, but they did. So what we need to do is we actually need to edit the configuration file of the actual of the device so that it'll actually set up a particular pin on the actual Raspberry Pi at a defined logic level so that it can read the data coming from the actual temperature sensor. So in order to do that, we need to type in manual commands into the actual Raspberry Pi. So sudo, which is actually the admin command. So you're running this command as an administrator. Nano is actually the text editor, which is built in to the actual Linux distribution. And then we need to actually tell it what file we're actually looking to edit. So in this case, it's located under the boot folder, and it's called config.txt. So once you get in there, you then have the config text file loaded up. As you can see, a lot of just words. The config text file is read by the actual Raspberry Pi when it first boots. It's used to actually set up things like HDMI. Also used to set up. It's used to set up for the older Raspberry Pi. It's used to set up the BNC output or VGA output on there. And there's also some other settings there as well for sound, I think. So what we need to do is the easiest way is to scroll down to the very bottom of the code. So what we want to put in is down the bottom. All right. You don't have a key, you don't have a mouse, so page down, arrow keys down, all the way to the bottom. So line of code that you add is just this one little line of code, DT overlay W1 GPIO. That tells it that it needs to enable the W1 on the GPIO pins. It's always best to comment your change, because in 12 months' time, you're going to look at that and you're going to go, what the hell did I put that in there for? Can't remember what that piece of code is. So I just put in enable temperature sensor. It's relatively simple. Explains what that actual line of code is. Then you need to actually save the file. So again, we don't have the mouse, we can't click the little picture of the floppy disk to save. Control O shortcut key actually will write out the file, prompts you for the file name that you're going to save it as. Just pressing enter saves it as the same file name. Once you actually press enter, it lets you know that, yes, I successfully wrote this file out and wrote out 87 lines worth of data, and then exit the editor by pressing Control X. Now, if you forgot to save, it will prompt you and ask you, do you want to actually save the file, yes or no? So if you did make some changes and you actually screwed something up, and you overrode the maximum USB current, for example, so that you can potentially blow something up that's plugged into USB, and you didn't want to save it, you can just Control X, exit out, and it will actually prompt you, do you want to save or not? You can say, no, don't save, and you haven't wrecked anything. So restart the device, and then once it's actually rebooted, you can now actually start to receive the data. So listen for the actual temperature. So we need to actually set up the DS18B20. So there's an actually number of options available for the sensor. Now, Alex's temperature sensors that he's made uses exactly the same chip as what I've used. So what I've actually used is I've used the little chip itself and a little circuit board. The circuit boards have got a couple of resistors on them already and a little LED light, just to let you know that there's definitely power there. And I'll explain what the resistors are for soon. Then there's the bullet style node, which is what Alex is using. The advantage of those is that they're actually waterproof. So most of them are waterproof. So if you wanted to, outside of Christmas season, you can actually just put that outside and have your own home temperature monitor. So dual purpose, just disconnect your Raspberry Pi from your box, plug it up to power, put your temperature sensor outside, and you've got live, what's the temperature outside? Oh, there it is. Alternatively, you can actually buy a board which actually already has the chip on. So I like the idea of having it so I can remove the chip, because if for whatever reason the chip gets damaged, I can just pull it out, plug a new one in, off and running. So now we need to just connect the sensor to the Raspberry Pi via some jumper wires. So there's a couple of different ways that you can actually connect it up. So if you connect up a single sensor, all right, all you need to do is you have power, you have ground, and then you actually have the data connection which connects up to GPIO pin 4. There's a pull-up resistor connected between the data pin and the power. This is just to smooth out the data that's coming from the chip, to make sure that the data that's coming in is actually smooth and readable and doesn't get corrupted. You can also connect up multiple sensors. You can connect up, I think Alex said 40? 48. 48. So you can connect up 48 sensors to one Raspberry Pi. Why you would want 48 sensors in your controller box? Not really sure. But if you're really, really pedantic and want to make sure that it's not overheating, you can do it. You only need one pull-up resistor. That's all that's required. And the way I've done mine, though, I've used the same little circuit board for all of it, and I've wired it all up in parallel. And it's happy to have a resistor on each one. It doesn't actually, it's not making any difference. So the temperature reading that I'm actually getting is exactly the same if I just had one board connected as opposed to having all three connected. Now comes the trickier part. Each one of these sensors actually has its own unique identifier number. Now, I can show everyone what the little sensor actually looks like and how big the little sensor is. But as you can see, the sensor, the ID number for this particular sensor is 28-02156 64B8D6FF. The chip is so small, there is no way they could print that on there. So the only way you can get this is to actually ask the device itself, what is the ID number? So what we need to do is, again, we need to SSH shell into our Raspberry Pi, get in, and then we need to change to the devices directory. The way that Linux works is everything's sort of referred to as a directory. Every device is a separate directory within the operating system. So we need to go into that directory. So if you're familiar with the old DOS commands, cd, change directory. So change directory into the system bus W1 devices. And then we type ls, and it shows us the exact ID number. Now what I did for all of my temperature sensors, I bought 10 of them, and then I made up little yellow flags with an ID number written on. I then opened up Excel. I put that little ID number with the actual ID number that I got off of the actual temperature sensor into my Excel spreadsheet so that I know that this particular one is this ID number, this one's this ID number, etc., etc. So if I did need to swap them over, I know which one it is, and I just need to change my little bit of code to actually match. If you've got multiple connected, you will see all of them listed one after the other. So you then got no way of knowing which one belongs to which ID number, and you're going to have to then unplug and plug them in until you actually work it out. So what we then need to do is we then need to actually jump into the sensor to read the temperature. So we again change directory into the actual temperature sensor itself. The good thing with Linux is you can type cd 28, press tab, it'll autofill the rest for you. You don't have to type it all in. Press enter. And then you ask it for the catalogue of the W1 slave part, and there's our temperature. So next to the actual T, it says 22,750. Now, as far as I remember, these particular sensors will go up in 0.05 degree increments. 0.06, thank you. They will go up in 0.06 increments. So they are very, very accurate. So you just need to get the number, divide it by 1,000, and that's your temperature. If you want to see the temperature go up, put your fingers on it, type your command again, up it goes, take your fingers off, blow on it, down it goes. So that's great, but it's not really very helpful. You don't want to actually have to be logging in all the time to actually see what your temperature is. So what I did was I created a web page to actually display the information. The good thing about the web page is it can be viewed anywhere. It can be viewed on any device. You can get your phone out. If your phone's connected to your home Wi-Fi, you just need to put in the IP address of your Raspberry Pi, and there it is. There's your temperature. So you can look at it on your phone. With a web page, you can customize it any way you want. You can have it send you an email every minute with what the temperature is with the right bit of code. You can have it send you an email every hour. You can have it so that if it hits a certain predefined limit, it will actually send you an email. If you've got SMS functionality built in, you can have it send you an SMS text message. So doing a web page means that you can have a lot of flexibility of how you actually get that information. And having a web page as well means that if you set up your router, forward the ports through, you can be at work. You can log in, you can see what the temperature is inside your controller box at any time of the day or night. So to create a web page, I created the web page in PHP. It's the easiest way to actually talk directly to the hardware, is with an actual PHP code. So that's the sample page to actually create, to actually read the temperature. So we're reading the actual temperature sensor. We then need to actually read it line by line. We then need to actually get the temperature from the second line and then format the temperature in some way, and then we echo that out onto the actual screen. So you can create the web page two ways. You can either create it on your local PC and then upload it, or you can create it on the Raspberry Pi itself. Creating it on the Pi means that you don't have a backup of the data. You can create a backup. It's just a lot more steps involved. Creating it on the PC just means you've got to do all the steps that you would if you created it on the Pi and then you wanted to back it all up. So again, you can create the page on the Pi, log into the SSH shell, and with that same nano text editor we used earlier, we can use that to create a whole brand new file, all right, and then manually type in all of the code that we need to actually have the temperature sensor read. So that involves just going into the current web page directory and creating it. Creating it on the PC, there's advantages because you can make the page in whatever program you want. So if you wanted to use an actual HTML editor to make the web page, you can use a HTML editor. You can make the web page. You can make it display how you want. You can format it a bit easier without having to learn how to code in HTML or PHP or anything like that. So that definitely has its advantages. And then you just need to upload the files. So the Falcon Player gives you the ability to easily upload the files. So you can just go to the upload section, choose your file that you want to send it to there. That then will automatically put it into the actual scripts folder because it treats a PHP file as a script. So even if you upload it to the music folder, it's going to put it into the scripts folder because it's a bit smart and it knows this type of file is generally a script file. So then you just need to copy the file from the uploaded location to the location where you can access it from the web browser. So just using the copy command, you can then copy it from the scripts folder to the actual web server. Then you can do the reverse. So if you've created the pages on the Pi, you can do the reverse, copy it from the script, from the web server back to the actual scripts folder, and then you can download it from the Falcon Player page. And then you can just browse to the page and see what the current temperature is. Every time you refresh that page, that temperature will refresh. So if you wanted to do it for multiple temperature sensors, well, we just need to include those in the same HTML page. So you just add the extra sensors into the actual code, and when you load up the page, it'll show you temperature sensor, temperature sensor, temperature sensor, temperature sensor. So it'll show you all the temperature sensors in there, whatever you put in that HTML or PHP page. So you can modify then the color. You can make the temperature, different colors, or you can do like I did, which is actually overlay the temperatures on top of the actual picture of the box. So all I did was I just took a photo of the actual controller box, uploaded that, and then created, with some more PHP coding, I've made it so that it overlays the actual temperature on top of the picture where the actual temperature sensors are. So you can see from the example there that up the very top of the box, which is temperature sensor up there, that's 25.1 degrees. A little bit lower down is 24.6 degrees, and 24.8, and then down a bit further is 24.8. I also made a bit of a color graph on the side so that depending on what temperature it is inside the box means that that's the color that the font will be for the actual temperature. So you can easily bring that page up. You can quickly, at a glance, see that most of it's in yellow, so that's all right. It's an okay range. Now, because I haven't actually had this outside yet, I haven't actually successfully put any lights up yet, I don't know what the average temperature of the box would be. So it could very well be running at 40 degrees, and that could be quite normal. All right? So I would then readjust my actual temperature scale on the side to actually match more closely. If it was starting to get up to 60, 70 degrees, or say the temperature sensor up the very top, that said 60 degrees. However, the temperature sensor in the middle said 40 degrees. Well, that's telling me there's a 20-degree difference between the very top and the middle of the box. That might signify there's something wrong with the power supply. And the power supply is generating a lot of heat and sending that heat upwards, which is collecting in the top of the box. Could also indicate as well that maybe the top fan stopped working, or the top fan isn't in the right spot, and I should maybe move it. Add another one. I've set that web page up to refresh every minute, so it will actually just sit there. If I've got my computer open, it will just refresh the page every minute, and it will give me updated information. That's how I've set it up. You can set it up any way that you like. Alternatively, you can purchase one of Alec's wireless temperature sensors, which is all pretty much just plug and play. You just get the temperature sensor, put it into your box, plug it up to some power, and then with the receiver inside, right, set up, plugged in, turned on, it gives you real-time feed of what the actual temperature is. Alternatively, you can always buy yourself an outdoor weather station. They will be using pretty much exactly the same temperature sensors. You can run it through with one of the cables, put that inside your box somewhere, have the actual weather station inside, and it can be showing you what the temperature is inside your controller box. There's multiple ways that you can actually monitor it. As I said, just for $2 worth of parts, some time, effort, energy from my part, I was able to actually put in some temperature sensors. So each one of the sensors cost me $2 worth of parts. It was $1 for the chip. It was $1 for the actual little circuit board. They took a month to get here, but they were $1 and they were free shipping. So, so that's $3 worth of parts in there. The cables that I used to actually hook it all up, that's old PC case cabling for the lights and buttons on the front of a computer case. The connectors plug perfectly into the GPIO pins. And then I made up a little circuit board so everything's all plug and play. So I can easily unplug, take it out, plug in another one. Everything just works. Yeah, so that's at least another way that you can do it rather than running around with your FLIR camera like Daryl, who spent God knows how much money on it, just taking photos of the cat. Or oh yeah, that's right. Sorry, yes, it was your box. So yeah, so it's another way of it's actively monitoring what this is actually doing. And as I said, you can set it up any way you like. I haven't looked at yet, and I may still look at whether there's any way that I can trigger an event within the Falcon Player software that if it hits a critical limit, like you can set a critical limit to say 60 degrees, 70 degrees, that if it hits that limit, is there any way that I can actually shut down the Raspberry Pi and have the Raspberry Pi shut down and maybe even have it send something out to a relay? Yes, Darryl. Because I'm stuffing your cat in the box. Putting the cat in the box. And then when the cat gets hot, it'll run out and disconnect all the power. So it's possible that you might be able to actually trigger an event which will actually activate a relay. And if you've got a relay connected up to the mains power, it could actually just turn the mains power straight off. Well, you could do that as well. You could hook it up to your sprinkler system. All right, sprinkler system. Yeah, that's right. Water cooled. Water cooled from your sprinkler system. So you can just set it up.
Do you have to use that GPIO pin?
Yes.
Is that the only one?
That's the only one.
That's the only one that actually does.
So the only pin that actually seems to be able to be used for multiple purposes is GPIO pin 4.
Which is for the clock.
Yeah, but the clock, they're I2C anyway.
So
if the clock and the DS18B20 should be able to be on the same bus together.
Should be.
Okay, yeah.
Should be able to be. So that's pretty much it in relation to monitoring the temperature.